All right, let's go for some more review. All right, find the equation of the tangent line to the graph at the point 1, -2. Okay, so first we need to figure out, remember the tangent line, the slope of the tangent line is the derivative, okay? So we are finding the derivative to find the slope of the tangent line, and then we use that slope to write the equation of a line, okay? So first we need to find the derivative of this, so we can look at it and realize that it's probably going to need implicit differentiation because getting y by itself would be impossible. And so we're going to just implicitly differentiate and find the slope of the tangent line. Okay, so it's going to be, remember we're doing dy dx. So our x is our independent term. So we're going to do 2x plus 2 dy dx plus 2y dy dx equals 0. Then we subtract 2x from both sides, and we get 2 dy dx plus 2y dy dx equals -2x. And then we factor out the dy dx, and we end up with 2 minus, or plus 2y equals -2x. And then we divide by 2 plus 2y. And you may have divided that 2 out first. That was probably, would have been a smart idea, but I didn't do it. That's okay. It doesn't really matter. It will still turn out okay. So in the end, we have that dy dx equals, we're going to factor out that 2, so we have -x over 1 plus y. So that's just our dy dx, okay? And then we want to find the slope. Okay, so we need to find the slope of the tangent line at the point 1, -2. Okay, so when x equals 1, what is the slope of the tangent line? Because remember, this does not have a constant rate of change, so the slope of the tangent line is constantly changing. So we want to find the slope of the tangent line at 1, -2. We just plug that in. We plug those points in. So we could write this, if we want to keep proper notation, y prime of 1, excuse me, y prime of 1 equals -1 over 1 minus 2, which is -1 over -1, which is equal to 1. Therefore, the slope of the tangent line is 1. And then all we have to do is write an equation. And I always suggest point slope form. I would not suggest anything else. So I would just say y plus 2 equals 1 times x minus, or x, yeah, it is x minus 1. I was going to say x minus 1, right? Because it's y minus y1 equals the slope times x minus x1. So that is the slope of our tangent line. All right, let's look at the next one. And it says, find an equation of the normal line to the graph. Okay, so remember, the normal line is perpendicular to the tangent line, which means we have to find the slope of the tangent line, and then, excuse me, gosh, pretty nose. Okay, we have to find the slope of the tangent line, and then we just use the opposite reciprocal slope to write the slope of the normal line. Okay, so we have to find the slope of the tangent line, which means taking the derivative, and we have the cube root of 2x minus 1 squared. So this is really, we can rewrite this as y equals 2x minus 1 to the 2/3, because otherwise that is just going to be, it's just too hairy to even figure out what you're supposed to do there. So then we're going to derive, and we're going to recognize that this is a chain rule because we have a function inside of a function. Okay, so we're going to go 2/3 times, the inside stays intact, and then we subtract 1 from that, so we're going to get -1/3 there. And then we tack on the derivative of the inside. So we have 4/3, because this 2 right here comes up and multiplies by the 2/3. We have 4/3 times 2x minus 1 to the -1/3. Okay, and then that is our y prime. We should definitely put that instead of putting equals, because that would make people think that that we're still talking about y equals. Well, y does not equal that. Y prime equals that. So I really should have put y prime right here. Okay, so now y prime equals that, and we want to find the normal line at 1, 1. So let's find the slope of the tangent line first. Well, we plug 1 into this equation, and we get 4/3. 2 minus 1 to the negative 1/3. So that is 4/3 times 1 to the negative 1/3, which is still just 1. So it's 4/3 is the slope of the tangent line. And so the slope of the normal line is going to be, yeah, that's the slope of the tangent line. Okay, just making sure. The slope of the normal line is going to be the opposite reciprocal of that. So it's going to have a slope of negative 3/4. So the slope of the normal line is going to be negative 3/4. And so when we write the equation of the slope of the normal line, we could just y minus 1 equals negative 3/4 x minus 1. Because the normal line goes to the same point, we just use that, and we just use the slope that we figured out before. Okay, let's do the next one. All right, it gives us a bunch of information and then tells us to find stuff. And so this is one of those abstract type ones that doesn't really, like, sometimes they're almost harder to do because you're like, can you just give me an equation and I will derive that equation, right? But this doesn't have an equation. It just says there's one function of t, we multiply it by a different function of t, and we want to find the derivative. Okay, so if we have some function of t, which is r of t, and then we have a different function of t, and that little box should be multiply. Hopefully in your book it says multiply. So let's figure out what the derivative is. Well, this is a product rule thing, so we are just going to write r of t and r prime of t, and then s of t and s prime of t. Oh, I said t and I wrote x. Okay, s prime of t. So the derivative of these would be r prime of t times s of t plus s prime of t times r of t. And we're going to find it at 3. Okay, so the derivative, so we write this d dt evaluated at t equals 3. That's how we can tell that we're, like, tell somebody, notation, that we are evaluating this at 3. And so then we would set that equal to, okay, so r prime of t shows up, r prime of 3 is up there as 3. And s prime, or s of 3 is 2. And s prime of 3 is 5. And r of 3 is negative 2. So we have 6 plus negative 10, which gives us negative 4. Okay, so that's the first part. Now it's asking us to find a quotient of the two. Okay, so again, we just use the quotient rule. So we say low d high minus high d low, square the bottom, and away we go. Okay, so at t equals 3, so again we're going to go d dt at t equals 3. Well, s of 3 is 2, r prime of 3 is 3, r of 3 is negative 2, and s prime of 3 is 5, and then s of t squared. So s of 3 is 2, and so that squared would be 4. So we have 6 plus 10 over 4. So we have 16 divided by 4, which gives us 4. So the derivative of that at 3 is positive 4. Okay, and then let's look at a composite function between the two. So we're going to use the chain rule. So we use the product rule, then the quotient rule. Now we're using the chain rule. And we're going to say, okay, R is the outside function. So the chain rule says I take the derivative of the outside function with the inside function still intact. And then I take the derivative of the inside function and I hook it on to the end, okay? So d dt evaluated at t equals 3 is going to be r prime of s of 3 times s prime of 3. Okay, well, let's see. S of 3 is 2. So this equals r prime of 2 times s prime of 3. And it told us that r prime of 2 is 4. So this is going to be 4 times s prime of 3, which is 5. And we get 20 for our derivative there.